Alright, we're back. I got the pins all leveled out, and we found the real problem was that the rod has some issues with it. So this is the rod we're using. It has a little bit of twisty in the top up here. So when you look at it, it's got a big whoop and a little to it. So there you go. So when you stick another rod up on it here, you can see the difference. It's got a little bit of a twist to it right there. So that doesn't work too good. That's why it kept sliding over on me. Got a big bow in the damn thing. This one here is straight. We're going to use this one. See, that's why you let the owner pick out his own rods. That ones are straight. We checked them. They're good. Okay, so that's why I kept sliding over on us, and that's why I keep giving me different dimensions. Big changes, not little changes. If these things weren't so flexible, that would really have been noticeable. Okay, now we got to re-measure the whole weight because now the rod has changed.
Did you get that bearing that fell on the floor?
The one I dropped? No. Did I drop one?
One of those big ones.
Big one? There was a big one on the floor? Better than a light one on the floor. Okay, well, first thing I do is measure the rod. We get to start over. Yeah, I don't see the bearing on the floor. There it is. It's trying to get away. At least it's zeroed over here already. That's a plus. Okay, how do we work on the weight now? Let's see, this one is heavier. You like them heavy parts.
Mm-hmm.
This one's 10 grams heavier, 10.2. That's why it was bent, it was too light. 438.3. 38.3 to 438.3. I think that's the number. You like that number?
Mm-hmm.
438.3. A lot better. Okay. Off. Got to put a little extra weight on here. It helps to put all the weight on there. Move our side to side here. Oh, I remember what I was doing before. I leave this magnet off. I forgot about that. Because even though I have a steel plate, welded to aluminum plate, these are steel. The magnetism affects the rollers. I forgot about that. So we leave this magnet off. It does affect it. I made a comment about that earlier, if you remember. That might have been a little bit of a problem too. Okay. Seems to be zeroing out good this time. Let's go check this rod. We had some numbers before, remember? Back on there. Back on the rollers would help. What did we have before? We had 460. We have 3. We've gained weight. She was going 1, 2, staying on 2, and I just dropped to 0 and stayed there. Nice scale. Four, 464. That's what we had before. 6, 4, 5, 4, 5, 4, 5. And then 4. And this one was 0. That's what it like before. Ooh, I like this. It's repeating better. That low number we had before is gone.
Mm-hmm.
It's now high. The whole number went up, so we had both ends went up higher. Just the high side, so low side. Let's see. Not zeroed again. Damn floating 0 is a problem. 0. There goes the drop back down. 3, 4, 3, 4, 3. 3. 2, 3, 2, 3, 4, 3, 3, 3, 3. Flip it. This one was 5 and 6. 4 is 5, I mean. 5, 4, 5, 5, 6. 6, 6, 6. Staying on 6. 6. Like 6 this time. Alright. That's about 2/10 repeat from before. Okay, let's see what this one does. About half a squish from falling off the edge there, you notice that? See, now the rod's not doing the flip thing like it was doing before. And see, now it stays put when you bang on it. There's a gap back there still. That's a lot better. That should have been first clue. It's screwing me. There was something wrong. All right. 2 grams heavier overall. This one's 265 now instead of 262. Seems to be a 5, 6, 7, 4, 6. 6 seems to be the magic number today. There's 8. I went the wrong direction. 7. 7. See if this thing zeros. There's 0, 0, still 0. It likes 0. I like it when things like to be 0. That's good. At least something's halfway accurate. Okay, this one's going to be, we were at 65 before. It's gained weight. Now we're up to 9. 9, damn. Way up. 0 still. Come on, get one. 7, 6, 7, 9. Seven, 7, 8. 7 seems to be the one this time. Now we do a flip. Check the other half of it. Come on. There we go. See, we're almost off the roller over here. Yeah, that's a close repeat. 7. 8. That's pretty close. Duplicated, almost identical. I think I use 8 on that one. 0 again. Heavy. Nine, 0. It's going up. It's going up a number. 266. 9, 6, 0. Fluctuating. 9. So that's with a 2 gram window. Okay, so of course now this isn't 0 anymore. Scale between 1 and 2. Now it's 0. Now it goes to 0. Now it's -1. And 0 again. It can't decide what it wants over here. It's 0. Now it's stabilized. It takes about 30 seconds to figure out where it wants to be. Wonderful. Okay, so now we need to reverse these 2 stands because the big end will be on this side and the low one will be over here. So I'm going to drop that way on down. Connect it off. Oop, too close. They don't have to be perfect, but you know, in the neighborhood would be nice. Okay, so now we're going to flop it. We're going to do the other side. Okay, looks pretty even. What do you think this thing's gonna do? I think one of these days I'm just gonna whack the piss out of it and make it fix it. What do you think? Like nail it hard.
But use this bent one.
I could use this one here. It wouldn't hurt it, would it? I can't use yours. I gotta use the other yours. You use the bent one over there. You can see how much better it works when the rod's not bent for one. Alright. So now we're on the small end. So instead of being 2 something, we're now 1 something. We're 172. Let's think about 5. Yeah, that's at 4. 6. That's nice. How was our 0? Did we 0 it? It's not 0 if you don't have that on there. Zero. That's good. We have what, 5. Now we got 3 and 4. What side of the road are we on? Oh, I didn't measure his. Damn it. I'm gonna have to go back and do his later. 72.4. Lost a 10th. And you're on the. I'm on the wrong side. Yeah, close enough. Okay, 0. Try this again. So 2, 4, 5, 4, 5, 4, 3, 4, 3, 4, 5, 3, 4, 4. Likes 4.
Mm-hmm.
Quit moving. So likes that number. Okay, now we're going to flip it. Before it didn't make much change. Three, 4, 3, 3, 3, 3, 3. I think it likes 3. What do you think? 172.3. That's pretty accurate. I like that. 10th. Bet you this one's not that close. We're 0 again. That's good. Definitely need a better scale. I got a bunch of little pendulum scales that you're supposed to use back in the old days.
Mm-hmm.
They're pretty accurate, but the problem is that as they teeter up and down, the rod, the weight changes because this one's being fixed.
Mm.
It affects the scale a lot. So you have to have a digital scale where it doesn't move to use this tooling. Okay, 178.6. 4, 6, 5, 4, 6, 5, 6, 5, 4, 5, 5. Makes 5. 78.5. Of course, then I went to 7. 6, 8, 7, 7, 7. So something happened. Scale is at 0. Now it's at 1, 0 again, 0. It's going to be 5, 6, or 7 up here. 1, 7, 8, 5, 6, 6, 6, 6, 6, 6. Seems like 6. See how things go quicker when they start repeating? works better. Scale a little bit there. Okay, what do you have before? 78.6 or 78.8 now. 3/10 up. 178.8. We picked up 2. 8. He likes that 8. And then there's a 7. Just to confuse you a little bit. 178. 7. Still 7. Stabilized on 7. And 0 again. Stable 0. Up 9, 0, 9, 9, 8, 7, 0, 8, 8, still 8, likes 8. I think 8's the number it likes the most. 8, 9, 8, 9, 9, 8, 8, 9, 8, 8, 9, 8, 8. I'm going to go with 8. I'm going to say 8. So that's 2/10 different than the other side, which is a hell of a lot better than the other side was 3 or 4 out. It's holding 9 right now, but confuse it again. 7, 8, 8, 8. Likes 8. 8's a good number for it. 8, still 8. 8. Okay, Mr. 8. And back to 0. Okay, shut that damn thing off so I don't have to look at it. Okay, wasn't that exciting? Okay, now we got to figure out what the errors and all that stuff was. I'll calculate it later. Okay, now your accuracy is, we measured the full weight, we measured this side, measured this side, well, actually we measured this side first, then we measured this side. Now, theoretically, if you add that and that together, you should get the total again, right? Now the error is the difference. That tells how accurate your tooling is. The closer that error is, the better. It used to be I couldn't hold 10 grams. Yeah, not very good. Let's see what we get today. With this tooling, it was down to about 3 grams. Big improvement from 10. Okay, so this one here, we got our average weights between the two sides. We got 6 and 0 and 3. So I'm going to call that 460.3 is the average of all those weights. The average of all these weights is 178.7. That's for our rear rod. Okay, the front rod, we got 172.4, and this one over here, we had 8 and 9. That's pretty close. How do you average an 8 and a 9? There's some 0s and 7s in there. I'm going to go to 9. 265.9. That's the most frequent number. Okay, so now we take the front rod, 265.9. We add in the 172.4. Gives a total of 438.3. What'd the rod weigh?
438.3.
That's pretty damn close. Can't get much closer than that, see? See, we got 438.3. I looked over all these numbers and added them up and averaged them. Came up with that number. I took these numbers here, which are, these are the, on the one side and this the other side, so that's a 1/10 apart. We had a high, so I just went with a 4. So you add those two together and we get our total weight that we had. Where was our total weight? This one, right here. That's pretty, so identical. That's pretty close. Now I think we're going to hold that air on the rear one. I doubt it. Let's see. I'm surprised we got that close. I was hoping to be within 3 grams. 460 point. Nope. 460.3 was my average for the big side, plus the 178.7 equals 639 even. Got a 6/10 error on that one.
639 and 6/10.
Yeah, so here's our 6/10, and we came up with 39. So we're light. We came up light. So now we go back and look at my average numbers and see where my error is going to happen. Okay, this one here we're bouncing around 7, 8, 5, 6. That average is pretty close. This one over here, we're all over the place. We had 6 here, we had 4, we had 0 and 3. So I went up to 3 on this one, I came down from 6 on this one. So this one could go up a couple tenths easily. But we're still going to be 4 tenths shy of what we needed. Most of the error is on this big end. We got, what, 6 tenths is our error. So I'm going to add 2 to this and 4 to this one. 178.9. 460.7. Because most of the error was on the big end. So we got what now? We got 460.7 plus 178.9 equals 39.6, 39.6. Okay, so our number comes in correctly that time. Okay, so those are the numbers I'm going to use. So the rear rod was giving us a lot of problems, and it still gave us problems at the end. So I'm going to circle the numbers I'm going to keep. And when I come back later, I can look at what I did. And we're going to keep the big numbers up here. These big numbers we never use. These small numbers are what we use. So we have to go up here and put in what we got. Reciprocating end, crank pin end. That's on the front rod. So front rod crank pin is the road big side, 265.9.
That's the wrong. That's the.
Am I in the wrong one?
Yeah.
I'm good. 265.9. 172.4. The big rod. The crank pin end is on the bottom. 467. The other one's 178.9. Because you don't use the total weight, you use the individual weights over here. Okay, so now we got all our numbers here. So we got the piston weight, which is here. We have our rod weight individually over here. This is where we start adding all this stuff together. So we got to add on our wrist pin for both rods. Those are 2 lighter numbers, 172.4 and 178.9. Now on a car, you're going to want to equalize all these weights. On a Harley, we don't give a squat because it's all a common crank pin. Basically, it's a one single cylinder. You add them together, it doesn't make no difference. So it's a waste of time making it better. Unless you want to play. But good luck on making the pistons the same weight. Let's see, what do we got on the reciprocating and rotating end is the big side. So we want the front rod was 265.9 and the other one was 460.7. Okay. Okay, our piston weight was 687.1. Our rotational weight, crank pin was, where's our crank pin weight? 603.0. Okay, that gives us all the weights that we care about. There's only 6 weights that matter out of all that stuff we did. Okay, now you got to add these together and add these together and get our numbers. You do that in your head? No? Why not? Change this down to this view. Still can't read anything. You can see a damn thing in this camera. Yeah, we'll see. Okay, so now we got total reciprocating weight. That's the top end. All the stuff going reciprocating up and down like this. Rotation goes in a circle, reciprocating goes up and forth. Okay, so we got 687.1, 172.4, and 178.9 equals 1038.4. I always double check. 687.1, 172.4, and 178.9 equals 38.4. So that works out. Okay, now we do the rotational weight. So that's a 603, 265.9, 460.7 equals 1329.6. 603, 265.9, 460.7. 1329.6. Okay. Total rotating weight. And then once you bring the reciprocating weight back down so you can see it better. Okay, multiply times factor. What's your factor? It'd be called 60%. Racing factor. Okay. So, we gotta figure rotating weight, reciprocating weight, we already did. Multiply it by that. So, what are we doing here? Multiply reciprocating times your factor. So you take the reciprocating weight to 1038.6. Now 4 times 60%. See, I have a percent here. If you don't have percent, multiply by 0.6. Does the same thing. 0.6. So that'll be 623.04. We added another digit. How's that look? 1038.4 times 60% equals. I think I did something wrong. What do you think? It's close though. 624, 623. The zeros the decimal's in the wrong spot. You notice that? 1038.4 times 60%. 623.04. So you can use a percent key or do the decimal. Okay. Now basically what it means, we used 60% of our rotational weight is what we're going to add to the balancing weight. So whatever's going up and down, we added 60% of it. Now everybody keeps bringing back comments about hanging a rod off their dick and coming up with some number, and it's supposed to be accurate as you turn the flywheel in a circle. I haven't got a clue what the hell they're talking about, but at best that's going to be a 50% balance factor. But I think that's a 100% balance factor if you're hanging it by your turret off here. So you're all screwed up. So this is how we do it on a Harley. I don't care about other vehicles. If you don't have the right equipment to do the job, don't do it. Okay, now we got to add in our rotational weight, which was way up here. 1329.6. Okay. Total ball weight for 2 wheels. That means we add in these two numbers together. 623.04. That averages to 0. Plus 1329.6. That's going to be 1952.6. That's your total bob weight we need. Now we're going to divide that by 2 because we have 2 flywheels. Divide by 2 equals 976.3. Okay, I'm going to recheck all those numbers again. Okay, 623 plus 19, no. 623 plus 1329.6 equals, divided by 2 equals 976.3. Here, I got the same number twice. Okay, so that's how much bob weight sticks in that hole right there to balance it. And as I recall, nothing on our whole motor has that with a piston hanging off the end of it equals that number, did it? I didn't think so. Alright, so that's how you do all that. Now we gotta find the bob weight. Where's Bob at? What number they like? 900?
976.3.
Mm. $10.10. That's what I use in a normal 45. We're lighter than a normal 45 by 40 grams. What's the difference? Actually not 40, it's 30, 34 grams. See, this doesn't fit in our Sportster. Big old crank pin hole over here, you see? Yeah, a little sloppy. Okay, so we're going to wind up having to make a weight. That's light, really light. That's the lightest weight I got over here. KR 1200. That's not going to help us. Sports is 1100. So we're going to have to make a weight. Because I don't have any lead ones pre-made for this application. I don't know why we not have a weight made for this already. Because every one of these is different. Okay, so now we got to come up with the 976 number. So I'm going to go over here to our friendly Denley balancing scale over here. That's perfect. No, never had an issue with it. Does anybody believe that yet? We're going to take this off, turn it back on. What number do you want?
976.3.
Okay. So our minimum weight is going to be this much. Good. We're under 784. Now we start adding weight. See, that's my shortest bolt. Eight. 9. What number do you want?
976.
I'm at 40. 50. We're going to have a bolt. 60. 76.3. 1, 2, 1.
763.
3. I got 1.
9763.
Now we need something really light. No, 6. You want 6 or 3? Don't have anything lighter. Thought I had some lighter ones. Five, 4, 3. 3. What number do we want?
3.
4.
9763.
Okay, that's it right there. 9764. Or 774. 76 or 77?
76.
Oh, I'm way
9763.
off. I'm 77. You confused me. 76. No, that's not going to fly. Start over. 80. 71. 76. Was 77. 77. Don't want to use as light. 77. Oh, these aren't light enough. These are all the same. I did a light one in here. 75.8. That's too heavy. How about that one? We lost 2/10. Now we're 76.9. You want 70 what?
76.3. 9763.
I'll get there without. Use a different combo. Ooh, we're close. 76.6. We picked up one more. Five, 6, 6 again. You want 4? 3.
3.
3. 3 grams off. I'm gonna pick up 3 grams. Yep.
Use that. Get rid of that big washer and use some of the smaller ones.
I'm running out of small ones. Yeah, if they start stacking way the hell up, that's the problem. I'm gonna run out of a bolt. That's gonna be too much. No, 75. This isn't a full gram. $766, same number. Just done with different parts. Got it heavier. Yeah, that's the same. We get it 2 different ways, the same thing. So I gotta find a lighter one of these. $765. 4. There's 1. Which one uses lighter? $76.4. Bouncing between 3 and 4. There's 3. It says 3. Three. 76.3, right?
That's it.
Not 75.
763.
76.3. 76.3. Now can all that bolt together? That'll be the next problem. Can it physically bolt on all that to the flywheel? Okay. So, we know we need this. This is mandatory, we need this piece. That'll obviously bolt together. And that is not going to bolt together on that side. That is barely a long enough bolt. Yep, looks like it'll work. Looks like we have enough length. Yep. This has got 2 threads. This bolt. This one has more room. More holding power now. Of course, now I got this all mixed up over here.
I think that other washer was there too.
Enough room. $75, 76.4. So this goes on there also. Which is okay, we have room. So this one here only has 2 threads. That's okay. This one has more threads actually holding the flywheel. So it goes like that. And that can be balanced now. Where's your shaft? Just going by the workbench, it's heavy on that side. So this is our balancing shaft. We don't need all these adapters. We don't need any of the adapters. One of these two will fit in the hole. Not that one. Oh, this is a 45 motor, isn't it? None of these fit. This is for Sportsters, not 45s. So you can't use any store-bought tools. They don't make a 45 balancing kit. It's S&S. It's a good thing Dad didn't care about 45 motors. I'm guessing the small one here is going to be the 45. This one's probably Sportster. Yep, that don't fit. So this one here, that's all been polished on, must be the 45. Oh, look at that. Just because S&S doesn't balance Harleys doesn't mean I can't. Alright, so that's how it all goes together. You put that onto your trilling stand and it's, when it quits rotating, it's balanced. Got that? So that'll be the next thing to do.